Hello, everyone. First of all, thank you for attending. It's amazing to see this full and all of these people standing. So that's really good. And of course, you are here to hear from Javed Khan, who is the president of ADAS at Aptiv. Javed, before we start, would you like to give a quick introduction to yourself?
So it's great to be back and it's great to be doing this again. I know we did this last year and so much changed in the last 12 months. Excited to be sharing some of that here today. So I'm Javed Khan. I'm president of what's now Intelligent Systems at Aptiv. ADAS happens to be one of those intelligent systems that we've been building for a decade now, but increasingly we are building similar applications for newer edge devices, and looking forward to sharing more about how we're doing that today. So yeah, but it's great to be here.
Brilliant. Well, so let's start. Um, Javed, we hear a lot about AI and we hear a lot about edge AI, right? So can we start by actually assessing what has changed? Because we had intelligence in the car at the edge for a while. So what is different now?
Yeah, I think that's a question I get actually pretty often, and we've all noticed this the last few years, especially. There's so much interest in all things edge devices, and what's changed, right? Many of you might remember actually the term IoT goes back, frankly, like 2 decades, right? People have been talking about IoT devices for 2 decades, but the last 12 months, 24 months, we've seen a tremendous increase in velocity, and we believe at Aptiv that there are some fundamental reasons for that. So one is the compute capabilities on edge devices have just gone through the roof, right? The kinds of things that you couldn't even imagine doing on edge devices, you had to connect to the cloud, or you needed a data center. You can now do on the edge device. So that now allows you to run certain applications, certain AI models on the edge. That was not possible even 24 months ago, right? Uh, the other thing that's changed is you now have the AI models themselves extremely powerful and capable of doing things in a much smaller form factor. Right? So advancements in the AI models themselves, advancements in the compute capabilities now means you can do things on the edge that you couldn't do without much more powerful compute in the cloud. So that enables a new kind of use cases, right? Especially where latency is extremely important. So think about a car, right? If you tried to build an ADAS system 15 years ago, you would be subject to the latency of the network. You'd have to wait for that data center to respond, right? Now you can do all of that on the edge. So that is enabling just a whole class of use cases. The best place that it's manifested itself today, the most advanced intelligent edge device, is actually the car. Right? It's recognizing what it's seeing in real time. It's making decisions in real time. And I think we are starting to see that in a lot of other verticals, which is why it's a really, really exciting time for all things intelligent edge.
This is amazing. And I just want to go deeper into these use cases, right? So the car recognizing what it's seeing and acting upon it. Do you have any examples in the ADAS segment and also in the infotainment, or which areas in the car?
Yeah, so Aptiv, for those of you who may not be familiar, so Aptiv's been in the mobility space, automotive space, as a originally as a hardware supplier. We focused on radars and cameras and other devices that went into cars. But over the last decade, we focused on building out the ADAS system, the autonomous driving system, and increasingly there is the in-cabin experience system, which has become more and more powerful. So those are the two kind of stacks we've built. We call both of those as intelligent edge stacks inside the car. The reason we separate them is autonomous driving has to be safety certified. You cannot get it wrong. It has to be right 100% of the time. Whereas the user experience stack is a little less safety critical, but it has its own stack. It's increasingly driving multiple monitors, but it's also becoming increasingly intelligent. So the in-cabin experience stack is now starting to do things like recognizing whether you're paying attention or not, recognizing that you've left your kid behind in the back seat and alerting on that. It can actually eliminate physical detectors like your seatbelt, because it can, traditionally seatbelts were activated by a little sensor that sensed that you had plugged it in. Now, using the intelligence running in your in-cabin experience, there's a camera in there, can actually detect that. So you're now starting to eliminate certain pieces, certain components. So two examples of intelligent stacks running inside the car today at scale, right? And I think the auto industry doesn't get enough credit for what it's accomplished with these two stacks. I think we're going to start to see that learning. We're already starting to see these learnings show up in some of the other verticals.
I completely agree with what you just said. Being in automotive for a while, 5 years ago, automotive was a ugly cousin that was always behind in terms of technology with other industries. But now we are seeing this evolution of tech, this explosion of tech happening in auto. Actually, auto leading in terms of technology, right? So it's amazing. But now, going back to what you mentioned. One question I have, so we're talking about autonomous driving and ADAS. We hear a lot about end-to-end systems. What does that actually mean? How do they differ from what was before? What components are involved?
Yeah, so that's a good question. And actually, if you walk around the halls over here, you'll hear various kinds of ADAS systems talked about. End-to-end is the new kind of buzzword. The keynotes yesterday also mentioned some of it. The simplest way to kind of explain that would be the early years as the industry built out ADAS systems, they used AI for perception. So figuring out that there was a human, figuring out there was a traffic light, figuring out that a pedestrian was crossing the road. But what you did with that was often driven by rules, or was driven by a map, for example. So you'd use that input to then take somewhat static data to make a decision, right? I needed a map, I'd compare where I am and then decide whether I go left or right. Increasingly, the ADAS systems, and this is one of the things we are demoing in our pavilion, is they are using data to not just perceive what you're seeing, but also using data to decide how to move, right? So typical drivers navigate a curve at a certain speed, right, in a certain location. Imagine if you could train on that data. You can now mirror the behavior of other drivers. Simple things like braking. When you pull up to a certain traffic light in Vegas versus a stoplight in front of my home, the way people brake is different. So end-to-end systems not only learn how to perceive, but they also learn how to drive. The beauty about those systems is they solve the problem that ADAS has had of this long curve, long tail, where ADAS systems have been very, very good at getting 99% right, 99.5% right, but that long tail of edge cases, right? A cop suddenly stopped in the middle of the road, right? If you hadn't coded your system for it, you'd now have to go write code. And that made these systems extremely hard to keep up to date. But with end-to-end training systems, all it needs is data, right? So as long as it has enough data from previous people navigating that, the system just learns on its own. I don't need a map. I don't even need to have necessarily driven in that particular location, but I can learn from previous experiences. So that's what an end-to-end system is. Now it requires a lot more compute. Goes back to the first point I was making. That was maybe not possible a few years ago. But today, there is enough compute in these cars where you can now run these kinds of systems. And that's something we are building. The industry is actually spending a lot of energy on. I think the challenge is going to be to still get the price point down for these, because we all know that GPUs are kind of expensive, and most people still don't want to pay more than $30,000 for a car, right?
That is true. I love the explanation, but you know me, so I have more questions about that. So we are saying, and please let me tell me if I'm wrong. So with these end-to-end systems, you get the signals coming from the sensors in the vehicle. They go through this neural network that has been trained using data of users and drivers. and then you get an output, which would be the actuation of the car, so a brake or accelerate. Is that a good understanding?
Yeah, that's a good explanation. I think the only thing I'll add is how you actuate, how you drive the car. You've also trained on that, right? So not only are you learning what you're seeing, but you're also learning how to deal with it, and that's the kind of terminology, end-to-end terminology is used to describe.
And this learning, does it happen at the edge or in the cloud?
No, so the learning today does happen in the cloud, right? So over time, and there's an interesting synthetic data trend there too, which is you collect you've probably seen these cars with drivers with these lidars driving around practically every city, right? What they are doing is they are collecting data, but in some cases they are also not some many cases they're also learning how the driver is driving, right? So that data is then trained, is used to train models in the cloud, which then get deployed into these cars. Now, the actual real-time inference, if I may, right, the decision making does happen on the edge, but the training often does happen in the cloud. The other new trend, and you'll see examples of that, Aptiv spending a lot of time on this too, is you can only have so many drivers driving around in so many locations. But there is increasingly technology that allows you to generate synthetic data, which simulates what a radar or a camera could see in situations that you could just describe, right? So you can now artificially generate a scene, if I may, that the system learns from. So you don't necessarily have to have every possible use case or scenario collected by a real driver driving. So synthetic data is also helping with that. Now that training also typically happens in the cloud. So.
And this synthetic data, is my understanding that it has improved as well on what we can create. Because a few years ago, synthetic data didn't represent reality as well. But it seems that we are very close to really generating scenarios that are really close to what happened.
Absolutely.
Is that true?
Absolutely, yeah. I think you heard some of those announcements yesterday from various vendors where, and I think that brings up this other interesting distinction I make between digital AI and physical AI, which applies to synthetic data. So much of what the world was talking about the last 18 months was what I call as digital AI, right? It was digital input, AI in the middle, and digital output, right? The input was digital. What we do with intelligent edge devices like cars is the input is actually physical. It's not digital, it's physical input. And the output is physical too, right? So what that means is the combination of inputs and combination of outputs just got infinitely more complicated and infinitely more consequential. Like imagine getting an output wrong, right? Uh, you can't get it wrong at all with a car, right? So that's where synthetic data has a big role to play, because now you can simulate some of these physical input use cases a lot faster, and you don't have to kind of train on every possible scenario. But that's an important distinction we make at Aptiv, which is, when I talk about intelligent edge, we are really talking about physical AI at the intelligent edge, where there is a physical input, AI in the middle, and there's a physical output. And we believe that while that is harder, that's something that the auto industry has done very well for the last decade. There's very few companies that have done that effectively for a long time. There's a lot of companies doing digital AI very well.
No, I'm loving this because it really feels like this is a completely transition from what we had before, right? Now, one question, actually two questions that often I get and I hear when we talk about just end-to-end systems is, how do you make sure that the output in the system is correct and safe, and what your vehicle is going to do makes sense, is what the vehicle should be doing? This is one question, and the other is, you're training on the driver behavior. But what if all the drivers behave badly? How do you make sure that you have a good behavior in your car?
So good questions there, right? So firstly, you don't train on bad data, right? So there is a there is a validation process that we go through, and that's an important step that we have to make sure about our data. I think in terms of just the other checks and balances in place, again, there is an important distinction between physical AI and digital AI. There's two kinds of checks we have in place. There is the AI getting something wrong scenario, but there is also the failure of the physical components that you have to deal with, right? What if suddenly my left radar stopped working, right? Or what if my compute for some reason started running a little slower? So what we have to deal with, what we test for, is not just the resilience of the digital portion of your stack, but also other kinds of hardware failures. Right, and that is something the industry has done a great job of over the last. The industry gets accused of moving a little slower, and the reason for that, and for some reasons, is that they've done a really, really good job of making sure that there is checks and balances, fallbacks in place, both from a physical failure standpoint, but also from a digital failure standpoint. Now, what does that mean? Besides the normal testing with synthetic data, testing various scenarios, it's also about making sure there are some stopgaps and rules in place, which is there are certain behaviors that are just wrong for a car, right? So those you'll find are typically hard-coded, right? You're not going to do this because bad stuff's going to happen. So on the auto side of the house, the industry's done a very good job of combining those things. But obviously, there's a big testing component to it. And I think that is why we at Aptiv are really excited about how this can get applied to aerospace and defense and to these other industries, which we believe are in the very early stages of learning a lot of this.
Well, you just asked my next question. Because it seems that the trend now is the vehicle is almost like seen as a robot, right? So it seems like the core technologies are very similar to core technologies you use in other industries that also have mission criticality. So I was wondering, I want to hear from you, what about what other industries could benefit from it?
Yeah, so the two we are seeing a lot of interest in is aerospace and defense, drones obviously, and then robotics, and there's a lot of those around here. But stepping back, why do we think that this applies to these other industries? I talked about physical AI. To us, physical AI has some basic constructs that are needed from a stack standpoint. They sense their surroundings. They they perceive, and then they use AI to think. So we use the term sense, think, act. So they sense their surroundings, there's AI in the middle, and then they act on it. And that construct applies to aerospace and defense, drones specifically, and it also applies to robots, right? They all have sensors that sense their surroundings. They all now have high-powered compute that's doing something with it, and then they are all acting on it. So there's a physical input in the form of sense, there's a physical output in terms of acting. And what we realized was that for automotive, we had built this at scale. There's hundreds of millions of cars sold across the globe, right? And they all have this today, right? And we found that the similar patterns repeating itself in case of a simple robot too, right? So whether it's a robotic arm or some of the industrial robots that move around and move objects from one place to the other, they are sensing their surroundings, they're acting, they're capturing what's happening, and they're making a decision and moving. So they all need sensors, they all need AI running in the middle, and they all need to do something with it. So those are the two industries we are focused on, but I think that's just the beginning. Any physical activity potentially will need a similar stack.
That's fascinating. In terms of the robots, what do you have a demo in your pavilion? Can you talk a little bit more on that?
Yeah, so Aptiv recently announced a couple of partnerships with a couple of early startups. One is Robust AI and the other is Vecna Robotics. And we've got two of their robots in our pavilion next to the cars. And what we were able to do very, very quickly, so both those robotics companies were relying on cameras to perceive their surroundings. And in some cases, they had multiple stereoscopic cameras trying to get as much of a view as possible. And when the auto engineers look at the solution to this problem, for them it's a problem they solved 5 years ago, and they have much better solutions. So in our case, what we were able to do was we were able to replace those few $100 multiple cameras with one of our sensors. So we have a pulse sensor, which happens to be a radar and a camera together, right? So we're able to replace that. Now, what's the benefit? First of all, there's a radar and a camera in there. So now you can look around objects and so on. We've got a vision stack that already knows how to detect objects, learn what objects are. And more importantly, the industry does this at a cost and scale that is, unparalleled anywhere else. So we are able to do this at a cost structure in a distributed fashion that nobody else can. So as these companies are looking to scale, so both those companies, they get their first big order, and the immediate problem becomes, what do I do with my BOM? How do I make it more efficient? And that's a place where companies like Aptiv, have the supply chain, the ability to manufacture, but also the technology stack to kind of solve this problem in a much more efficient fashion. Ultimately, these companies are focused on their use case, right? They don't necessarily want to be spending all the time figuring out the sensors or what operating system am I going to use, how am I going to keep it up to date. They want to be focused on those use cases. So that's what we are starting to enable for some of these robotics companies.
That's fascinating, especially because my perception is that usually the robots were very specific in terms of task, right? But now with your stack, you can actually generalize it.
Absolutely, yeah. I think the robots historically, they've been around, but they were fixed function normally. And they were very good at doing a certain task. They were very hard to update. And they didn't have a lot of compute in there. So even if you wanted to update it with a more modern vision stack, you didn't have the ability to do it. But now you are not only able to do more advanced functions, but you can continuously update them. So imagine a robotic arm that is very good at recognizing certain defects, but there's a new kind of defect that the production line now starts to see. It can learn because it's got a camera in there, and it can be trained to now detect this defect in real time, and you can now push this out in real time. So that is these robots are becoming way smarter, and that just drives down costs, drives up efficiency.
Fantastic. We're getting close to the time. So one thing I really wanted to ask you is, last year you were starting an Aptiv. You're coming from an enterprise segment, and I wanted to hear from you now. Passing all this period, is there anything that from enterprise that you see similar happening in automotive and the other industries? Do you see any cross-industry knowledge?
Yeah, so Maite is referring to, I joined Aptiv. Before Aptiv, I was at Cisco. I was running their collaboration business, which is a combination of hardware and so video conferencing, hardware meets software. And I think one of the things that is similar with the auto industry and things like robotics and drones is the beauty of when software and hardware comes together. It just enables experiences that are, frankly, fun and magic, right? Things that humans do, right? So I think that is something that the auto industry is in the middle of. Aptiv builds both software and hardware, and that's allowing us to deliver amazing ADAS experiences, amazing in-cabin experiences. But the thing that is different is the thing I mentioned earlier, which is when you deal with the physical world, when you're dealing with things that move, lives are at stake. So the bar for AI is extremely high, right? You cannot get it wrong. And that's something in the digital world, I would argue we were probably not paying, we were paying attention, right? I think we all work on minimizing that, but the bar is way, way higher. And I think we'll only see that in these other industries too. The good news is that we've now got, going back to compute and AI models that are capable of doing that. But that's the big kind of learning for me, was the bar is just way, way higher, because bad things happen if you get it wrong.
That is very true. No, that's really, really interesting. And well, I'm gonna put you on spot here then. because we last year we didn't see much automation at CES. It was more like people focusing on L2 plus 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 plus, and now this year it seems that things have changed, especially now that we are focusing on end-to-end models. And yesterday I was at Jensen's keynote, and the provision, the timeline for full autonomy, L4 for passenger vehicles at scale is the end of this decade. What do you think?
I think we are pretty close. I'd agree. I mean, and you know, I think the other interesting thing about the last few years is things that we thought were 3-4 years out actually were a lot closer, right? So, but I would kind of rephrase the problem statement a little bit, right? Which is, if you have enough compute, if you have enough horsepower, if you have enough network capability, you know, yes, you can solve these problems, right? And you know, some companies want to sell a lot of compute, so yeah, put a lot of compute. But the question is, and when you look at something like the auto industry, the average person is not willing to spend more than $20 to $25 to $30,000 on a car, right? Now, can you solve that use case at a price point that's feasible for the customer, right? That's the question we are asking at Aptiv, right? And that we still have, and that's what we are focused on, right? So that might take a little longer, right? Because we need to make sure these models get smarter, they get smaller, and the compute capabilities are at a reasonable price point. So I do think some of these problems are going to get solved in the time frame you described, maybe even sooner. But when do they get practical, where the average person can use it and buy it and afford it? I think the industry, you know, it might take a little longer, and that's what we are really focused on.
That's an excellent point, because we are all seeing the prices of vehicles increasing, and what we want is actually, you know, that they become more accessible. So I think going back to this question is, do you think that the regular customer will have access to this type of technology in some point?
Absolutely, yeah. Right. It's the same point I was making. You know, the humanoids today, okay, cool. You know, I'd love to have one, but it's $80,000, right?
Yes.
I think these technologies will eventually will get there. I have no doubt in my mind. I think it's going to happen sooner than we all think. But I think the industry and vendors have to think about, how do I solve that for a customer at the right price point, and for the right use cases, right? Some of these use cases tend to be a little gimmicky, and I think no better industry has shown this today as the auto industry has, and that's why they are pretty well positioned to take advantage of this trend in other industries.
Brilliant. Javad, one final point here is, we are seeing auto becoming this place for innovation, right? We spoke about robotics, we spoke a little bit about drones. Are there any other industries that you think can benefit from what automotive is doing?
So I think lots of other industries. I think you know, there's healthcare is the other thing that comes to mind, right? I think there are certain healthcare you know, use cases where there's shortage of the right kind of employees. That's one thing we are looking at. But going back to just robotics and drones, I think we are in the very early stages of the kinds of things those things can do, right? We talk about drones sometimes in the context of defense and air travel, but if you think about the other possible use cases there, I think there's lots of other use cases that those two verticals can enable versus the narrower definition we might see today. And the same thing applies to mobility, right? I think it's one thing to have a self-driving car, but once you have self-driving cars, what are the other use cases that the world would like to see, right? Whether it's driving driving an elderly person around, or things like that will start to get.
Fantastic. Javed, I can't thank you enough for all of these insights. I absolutely loved the chat. So thank you very much. And please give it up some.
Thank you
some
for the great
applause.
conversation.
Thank you. Thank you.